Hello and welcome back to another video. This problem, we're given the function f of x is equal to x squared minus 1 times e to the x. Firstly, we want to find the derivative and the second derivative. The first derivative, we're going to use the product rule. Since we have this times this, the first term and the second term, I think it's helpful to think about it that way. So we're going to have the first term times the derivative of the second term plus the second term times the derivative of the first term. So, calculating this, we have x squared minus 1 times the derivative of e to the x is e to the x plus e to the x times the derivative of x squared. We have a power function, so you bring down the exponent, subtract 1 for your new exponent, which is going to be x to the first power, which is x, and the derivative of a constant is 0, so we can just ignore it. So, this is our derivative, and the second derivative is going to be the derivative of the derivative. So, we have the derivative of this first term plus the derivative of the second term. And you normally wouldn't separate them like this. You just go into solving the derivatives with product rules and power functions and all that. But if you notice, when we're taking the derivative of this, this is the same as taking the derivative of the original function. So we can say right off the bat that the derivative of this we already found is just this. So we can plug this into the beginning. So we have x squared minus 1 times e to the x plus e to the x times 2x. And then from there, we can calculate this derivative, which if we pull the 2 out first, then we're taking the derivative of e to the x times x, so that's another product rule opportunity. So we have e to the x times the derivative of x plus x times the derivative of e to the x, right? First times the derivative of the second plus the second times the derivative of the first. Now we can start to simplify this. We get x squared e to the x minus e to the x plus 2x e to the x plus 2 e to the x times the derivative of x, which is just 1, so 2 e to the x, plus 2x, the derivative of e to the x is just e to the x. Now, simplifying these, combining like terms and everything, we get x squared e to the x plus 2x e to the x plus another 2x e to the x is plus 4x e to the x plus 2 e to the x minus e to the x is plus another e to the x. So this is going to be your second derivative. And this was the first. So, part B asked us to compare the graphs of these, which we have done right here. And we can notice things where the derivative is going to be negative when something is increasing, or the derivative is going to be positive when the function is increasing, the derivative is going to be negative when it's decreasing. But when you have all these, it's kind of complicated to understand this. But if you notice, when the function changes from increasing to decreasing, right? So it's going decreasing, 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 then into increasing, its derivative is going to be 0. Same thing with this. This is our first derivative, so it's going decreasing, decreasing, decreasing. Then here, it switches to increasing, and that corresponds with the 0. So that's an easy way to not really worry about positive and negative values. Just correlate the changes from increasing and decreasing to the zeros, and you'll find that they line up if you have the right functions, which we do. Again, this is your first derivative, this is your second derivative. As always, thank you for liking and subscribing, and I'll see you in the next video.